Hello, this is Professor Khan, and we are in week 4, energy system technology EST-204. So heat sink design, and this week we will talk about air leakage. I'll start. Okay, excellent. So last week we talked about transmission heat loss, and we said Q equal A times U times delta T, and that was one aspect of heat loss, which is transmission. The second aspect is infiltration, which is also known as air leakage. So either you leak air to the inside, or you leak air from the outside leaks into the house. So it's good to know. It's good to know. Uh, what is the heat loss for that house. So we'll talk about the reasons what behind us trying to prevent air leakage. Why do we need to prevent that, and why is it important? We explain also the relationship between pressure and flow, and we would like to be familiar with the operation of and steps of blower door testing. This blower door testing is one of the most accurate ways to measure the air leakage in a house. And I have posted some videos of blower door testing process from YouTube on the blackboard, and I hope you take advantage of watching the steps. You might have to do that at some point. Also, we will talk about other methods for finding air leaks. Again, for a big house, it's really difficult to uh, pinpoint where the air leakage is happening. And again, it's a big deal to lose hot air inside the house to the outside, and vice versa in the summertime when hot air leaks into your house. We also identify and list the sealing methods available for residential buildings. How do we seal and counteract this air leakage? Okay, let's start. So, why is air leakage important? It represents 5 to 40% of HVAC cost. That is huge. So even if you have good building material and you have leakage in your house, that's 50%, 40% of your cost going to air leakage. Again, some people tell you the house need to breathe, but there is limit to how much it has to breathe. It should not be porous, and it will be better if we can control where the air is leaking and what air we're bringing inside the house. And if you think about it, also you don't want to bring polluted. You want the air to be filtered and controlled, especially if you have allergens, if you have dust, if you have particles, if you have humidity. You want to control the air coming into the house. You don't want to come from existing holes in your house. Okay, it saves energy, of course, and improve comfort. By comfort, I mean again, not bringing dust or humidity or allergens or any other objects inside. And also, it protects the insulation. Insulation is fragile, and once you have moisture in the insulation, probably it will start to grow some fungus in it, and it will start to deteriorate, and its insulation value will reduce. So the book does really good job explaining those advantages of doing air leakage. We also reduce the heating and cooling loads. So again goes with the cost and also the cooling load. If we do the proper calculation, probably you can cut down, instead of just throwing 3 tons AC in a house, maybe 2 tons is enough, and that is 12,000 BTU difference. So it is significant. We can control moisture, which is something a lot of people neglect, but it's very important. The more humidity you have in your house, the more cooling power you need to cool the house. We talked about that when we talked about sensible and latent heat. So we want to control moisture. You don't want the moisture level in your house to exceed 60%, because then you'll start growing again mold, mildew, and other stuff. And it becomes very uncomfortable, and again it will deteriorate your insulation. Reduce vermin access. Again, if you have a lot of holes in your house, you might have insects coming in. You might have like rodents. So it's good to seal the house and not have other creatures living in your house that you're not inviting and you don't want them there, especially if they're not paying rent. Okay, that's a joke. Reduce the air pollution from the outside. Again, we talked about allergens, and we talked about like smog and other issues. Yes, you need the house to breathe comfortably, but we also want to control the air coming inside the house. And probably during these times you understand how this is important to eliminate outside particles from coming into the house. Also to reduce water, excuse me, rainwater leaks. If you have rain and rain combination with wind, you might have some water coming into your house if you don't have the proper insulation, and you have some cracks that usually they're not a problem, but when there is wind and heavy rain, it might be apparent. It also improves fire safety. How is that? If your house is very porous and there's a lot of air, if God forbid there's a fire inside the house and there's air coming in, fire will eat all the air. And if there's holes for air to come in, probably the fire will go faster because you're feeding the fire with the oxygen. So again, a porous house or a leaky house can have a lot of possibility for fire. Okay, past and the present. We used to do rough estimation based on the crack size of the wall. People would go and eyeball the house and the material and say, okay, this house will be this and that, and they do rough estimation of how much air are you leaking into the house, and that's not very accurate, and that does not serve us to have very good airtight house. New methods: we use infrared camera. It's very useful during the winter to heat the house and look from the outside and find out where are the areas of leaks. If you see a lot of leaks, probably this is where you have a crack, and you might be able to go and seal it. We can use blower door testing, which is basically sealing and closing all the windows inside the house. You put a blower door, which is a door that has a big fan in it that will create a vacuum and negative pressure, and you can go with a smoke test around the house and see what area leaks the most. It's very difficult because you cannot see air, and small draft, if it's not windy, it's really hard to detect. So it's good to have a good method to detect where the leaks are. And it's very problematic in older houses. Probably if you have a new house now, the material are built differently and they can seal better. But if you buy a house that's more than 20 or 30 years old, chances are a lot of sealing material has got old and they have a lot of cracks in it. There's also a method called gas tracer method, which again, that's when you call a company and they will come and seal all the doors and windows and close everything and fill the house with gas, special gas, sometimes CO2, with something easily detected, and they will come back in a few hours and measure the concentration of that gas inside the house, and they can tell you roughly how much of that gas has leaked outside. So we want controlled air intake and moisture, and again, pressure and wind does change the air leakage. I mean, you might have a house that seems very airtight, but in a windy day, you can hear the air coming from small little cracks. Okay, air sealing principles. So for us to have any air migration or air movement from one place to another, you need an opening, a pressure difference, and if you don't, you can have two containers next to each other at the same pressure with an opening between them, and the air is not moving at all. You can say that okay, some hot air will rise and move, but hot air creates negative pressure because of density, and again, it has to do with pressure difference. Air leakage is also called infiltration, so it's the same idea, or sometimes called exfiltration. Infiltration is when the air comes from the outside to the inside. Exfiltration is when the air is exhaled from the house from inside to outside, and that happens usually during the summertime when you have cold air inside, and cold air is heavier, meaning that has more pressure, right? Okay. Would you think that a brick wall, building material, and insulation are not air barrier? Yeah, usually we do think that the brick walls or like cement walls are complete bare, but in reality it's not. Brick walls are more porous than you think, and if you talk to a mason, they'll tell you like even rock walls or brick walls, they have a lot of porosity in them. So it's better to insulate these walls from the inside or have some kind of sealant or paint, some kind of special paint to mitigate that. But some stuff that look very solid to you, that could be very leaky because you don't see the opening. Also, if we look at the video, some of the most area where you leak air is behind your electrical sockets. It's around the windows. It's the sash. It looks sealed, but probably it's not. So under pressure, it will leak. And the video actually is very interesting. So that's the air stack effect, meaning that when air blows through an opening, it will create negative pressure, and the the you'll have a different pressure. I will show you a demonstration that I do usually in the class, and hopefully it will work here. Like if I don't know if you can see me, but if you see this piece of paper, if I blow on top of it, what's happening? The the air moving across is creating negative pressure from in the bottom, and that's causing the water to rise, and that's what caused the air sheet to rise. So think about that, and think about the chimney. If you have wind, probably the chimney has a lot of negative pressure, and it will pull air from the house. That's why in a windy day you want not to use your fireplace and have some kind of a gate to close it or a door to close it. So hopefully this makes sense, and I can go for hours talking about air pressure, but if you get the idea that air does cause leakage and air velocity does create negative pressure, and once you have a difference in pressure, you will have air migration from one place to another. Okay, I'm not going to go too much into the physics of that. Let's look at that. For example, this is a house, and we can see the pressure difference. In the bottom we have negative pressure, and in the top we have positive pressure because it's lighter air leaking out, and as it leaks out, some this will be positive pressure over here, and in the bottom that will be negative pressure, and air will come in. You can use this to your advantage in the summertime. If the sun hits this house from the top, it's going to be hot, right? If you have an opening here, all the air will leak out, and the cool air from the ground will come inside, and it will cool your house. And that's what caused also the chimney effect. It's nice when you have that controlled, but if it's not controlled, probably it's not a good thing to have air leaking as it wills in your house. Manometer is a piece of equipment that we use to measure the pressure, and probably you will use that for duct system to detect leak. Again, we can measure air velocity, and we know about pressure leaks with air pressure. I mean, if you want to know if your tire pressure is leaking, if your car tire is leaking, probably you will inflate it, and you go with soap and water and look where the bubbles are forming, right? So also, if you want to know if the tire is leaking, you will inflate it and wait, and you come in an hour and see if the pressure remain the same or not. So pressure is the main indicator to know if there's an air leakage, or we can also calculate air velocity with that. Wind pressure. So we talked about wind. So if the wind is hitting your house this way, as it shows in the arrow here, this area will have positive pressure. So if you have any leaks in here, the air will go inside your house. What happens here? As the wind goes around your house, this will be a vacuum. So this will be a negative pressure, which will also suck the air, and the negative pressure will suck the air from the house, and your house will become leaky. So think about that. I mean, even in your car, if you're driving your car in the highway, you're going very fast, probably you'll have a lot of negative pressure. If you crack a window, you can hear it very loud because the air is coming from your car into the outside. And if you don't have the vent open, you'll hear a lot of noise. So also behind your car, you have a lot of suction, and that's what they call drag. And I'm not going to go into that now, but what I need you to know is during a windy day, your house will leak from the least possible openings. The chimney and exhaust pressure, we talked about that. So if you have exhausted outside, dryer, exhaust fan, chimney, or makeup air opening, usually during wind, they will pull more air, and it's good to have this opening controlled so they do not keep leaking air continuously. I mean, an exhaust fan that is open to the atmosphere all the time, it will bring a lot of air into your house, that more than you need, especially during the hot days or cold days. So if you're heating or cooling your house more than 20 degrees to the outside, probably you will create a lot of pressure difference. Okay, so I put a YouTube here. I'm going to also embed the video in Blackboard about blower door testing, and it's the most practical way to know how we know if the house has air leakage or not. And this is the standards. I'm going to ask you a question about how much CFM is needed. So 15 CFM is the required air exchange for each person in a house. So if you have a house with 5 people, you need 75 CFM of air exchange, which is cubic feet per minute. Any less, you'll have to provide mechanical ventilation. So let's say you did the lower door testing and you found out that you have 60 CFM leakage in that house. You can leave it as is and say, okay, this is enough for the house to breathe. If it was me, I will really like everything to be sealed, and I would like to provide my own mechanical ventilation with a filter to control where the air is coming from. Otherwise, the air doesn't come from anywhere, and you might not want that. There's a procedure in the book and steps. I invite you to look at those, and I'll also show you the post video that I have in this link over here. Okay, where to find air leakage? There are some possible areas, usually between frames, between opening, between linkage between drywalls. Even though it's painted, it seems like it's sealed. Probably it's not, and it's a good area to have some leaks. And probably if you see places that are not sealed properly and they just have paint on them, most likely over time the paint will crack and you will feel some air coming from there. And again, you can do a blower door test, or you can wait for a windy day and go with a smoker. They have this small little machine that produces smoke where you can go and trace the smoke. Another trick actually somebody told me is when you go into the basement, look for cobweb. If there's wherever there's a cobweb, there's an air leak or there's a draft, because spiders actually know. They put their web where there's an air leak because it is more possible for insects to get trapped into it. But probably you will see cracks between the frames, between windows, and so on. Another video about finding leaks, I will post that video as an embedded item in Blackboard so you can watch it right away. Very informative video. This is the tracer gas testing, which we talked about, where we can seal the house and fill it with gas and then measure it. You want something that's not harmful and something that you can measure. You don't put carbon monoxide, you put dioxide and you measure, and you need to have a specialist to do that, somebody who's trained to do these tests. This is the infrared scanner. Those cameras are very inexpensive. I bought one for the shop. It's like around $150, and it will show you where you have most of the leaks. And the red colors means that where you have the most leaks. And if you look at the cracks here, it's where you have a lot of the temperature leaks. Top of the window, underneath the window as well here, and also the small vents. So these are areas that you want to pay attention to when you are trying to retrofit an old house. So for duct testing, again, we don't want to have air leaks. Even if you have a heat pump, you want to make sure the duct is carrying the air that you conditioned and cooled all the way to where you want it. So to find an air duct leak, you need to use a smoke test. You can also use a duct blower to make a negative pressure, and then you use the manometer. How do you do that? If you have a blockage or if you have a leak, you measure the pressure with a manometer in one area, then you go to the other area and measure the pressure. And if there's a big pressure drop, you know that there's a leak in that duct. And the leaky duct is very troublesome, because that's where you lose a lot of temperature. And also it could be another problem if you have a hot air system and you have a leak in the air exchanger or air handling unit, and you're leaking combustion air into the duct. And that is something I want you to be careful of, because it could be toxic for the people living in that house. Stopping leaks, we can use caulking, adhesives. There are so many advanced adhesives right now that do the job. We can use gaskets, tapes, or liquid foam. Liquid foam is the least favorite one, because I'm sure that it has improved a lot since the past, but it used to dry up and deteriorate quickly. Or you can use blown insulation. So the blown insulation actually is very convenient. However, it also causes issues in humid areas, and it has to be done by trained professionals. And depending also on what kind of particles are you blowing inside the walls or cavities. More videos which I'll post on Blackboard so you can watch easily without clicking on them. Okay, the fun part, calculation for infiltration heat loss. We will do that for the project. I'm gonna go a little bit into the scientific part of it, but you don't have to worry about that. For you, all you need to know for our intended purposes is what is the infiltration rate for that room, and that's something you can find directly from the book. I think it's page 71, and basically it goes by the number of windows and doors in that wall. But if you look at it scientifically, it's the air height capacity, the amount of air that leaves the room per hour, times the volume of space in that room, times the temperature difference. So it looks like that. This is the air height capacity, this is the exchange rate per hour, this is the volume of the room, and this is the temperature difference. Okay, for you, these two numbers are provided in one number called the infiltration rate, and you can find that completely from the book. And if you are going to work as a technician that does blower door testing, probably the machine will give you this number. So it's the exchange rate. For the homework, for the project, you will find this rate from the book, and the volume is something you calculate. The volume of the room is the volume of it's the width times the length times the height. Delta T is temperature inside, temperature outside. Okay, here's an example. What is the rate of heat loss for infiltration rate for room that is 30 by 50 with 8 feet ceiling? Infiltration rate of 0.8. The inside temperature is 70 and outside is 10 degrees. So here I will multiply 30 times 50 times 8 times 0.08 times 60, which is the temperature rate, and you should get that heat loss per hour. So you can go and use the infiltration factor from the book. Over here, for example, a room, one outside window with storm sash and weather strip, kept at 75. The outside is 10. The room is 15, 12, and 8. What is the infiltration? What is the heat loss per hour? So if you look in the book, probably you'll find one outside window will give you the infiltration rate of this infiltration rate will be, so first you find the volume, which is 15 times 12 times 8 dt equals 65, and infiltration rate is going to be from the book. I will look it up right now, and it's page 71. And as I look down the table, it's I don't know if you can see over here, window with storm sash and weather set, we have 0.012, so that's 0.012, and you multiply all these numbers together and you get your heat loss from infiltration. Okay, I hope this makes sense, and please try to come to the hangout and let me know if you have any more questions, and I have posted the homework and the videos on Blackboard. Thank you.